Hi guys. Even when I'm not here, you can't get rid of me. So here's the deal. I'm going to be out 2 days, and you can't do anything unless I teach you something. My daughter has the flu, so I'll be out today, and I have a meeting to go to tomorrow. Let me silence this real quick. So you need to learn about selection statements if you want to move forward with any of this stuff. So here I am teaching it to you. So hopefully you can settle into this for a few minutes here. Hopefully I won't keep it too long here. And we'll just get into it. So we'll do some coding and some flowchart and pseudocode so you can kind of see how things are progressing, and then you can move into the assignment that I posted in Google Classroom. So selection statements, here we go. All right, so I'm going to kind of skip this slide. Really, it's kind of showing you how this code right here, it's a huge mess. It's what you would do if you wanted to like wash your dog. But what we want to do is avoid all of this spaghetti code, things that are going kind of all over the place. We're going to find better ways to go about this. So really that's what this is getting into. If I was in class, we'd talk about this more, but for right now, we're not going to. So last time we were together, we talked about this repetition statement. You've got a decision to make here, and then you want to do something, and you always come back to what that decision is. Here with a selection statement, you're going to make that decision, and on the yes side, you might do something. On the no side, you might do something. But the deal is you never come back to the question again. You answer the question, and that's it. And then you choose to do something based upon an answer. Sometimes you do something, sometimes you don't. Sometimes you do it on one side, sometimes you don't do it on the other. But you can't get back and forth, and you always have to exit as soon as it's all said and done. So we'll get through some simple selection. Two basic types. You've got one-way selection and two-way selection. One-way selection is that type of structure in which if something's true, you do something, and if it's not true, you just don't even bother doing anything at all. It's like it never existed. So here's the deal. It's called like an if-then statement. If it's raining, okay, you can answer that yes or no. Then take an umbrella. If the answer to this question is yes, you do something. If the answer to this question is no, you don't bother with the statement inside. The two-way selection structure is a little different. You still ask a yes-no question, but depending on the answer, you do something else. So if the answer is yes, you do something. If the answer is no, you do something completely, entirely different. You can never do both things that it says to do. So for instance, if hours worked is more than 40, you figure out your gross pay is regular time plus overtime pay, because you're getting overtime pay because you worked more than 40 hours. If you didn't work more than 40 hours, then you just calculate that regular pay. Okay? So let's kind of get into just an easy problem. How can we write the logic to say slow down if and only if your speed is above 65? Well, let's take a look. Let's go over to like a text editor here. I might do something where I'll do like a quick little pseudocode start, declare speed. Maybe I input that speed, right? And if that speed value is say greater than, and I can use symbols here just like I did in the while loops, 65 I think we said, then I want to say slow down. And if the answer to that's no, like if my speed's not greater than 65, I'm just not going to do anything. My program's going to straight stop. No big deal there, pretty simple and straightforward. There's no reason to print anything if my speed's not greater than 65, so I'm just going to leave it alone. That's what makes it a one-way selection structure, just a single alternative structure. So if my speed's greater than 65, print slow down. If it doesn't happen to be greater than 65, don't do anything. Okay? On the second one, we might talk about dual alternative or a two-way selection structure. So here we're going to try to get U of I if we get an SAT score above 1400. Otherwise, it's going to say we're not accepted. So we might say something a little like this. We'll do another quick program. We'll do start. Okay, we'll declare an SAT score. Right? We'll input it. And then we'll get into our processing, our selection structure. If my SAT is say greater than 1400, print accepted. And now here's the other part to this. If it's not greater than 1400, we need to say something. So I'm simply going to say the word else. I'm going to say print not accepted. So here's really the big difference between the two structures. In this one-way selection structure that I have here, I do something if and only if this is true. If it's not true, I don't do anything at all. In the two-way selection structure here, I'm going to do one of these two things, but I'm never going to do both. I can't print that I'm accepted and not accepted in the same statement or in the same program. So if my SAT score is above 1400, then I'm accepted. If I'm not, then I print I'm not accepted. So it's actually a pretty simple structure. It works really, really well logically, and the questions are generally really easy to answer. They're yes or no, true, false, and that's the way it has to be. Okay, so let's kind of look at some more of this stuff. So how we use it in Python. So basically it's pretty simple. We got a keyword here just like when we implement looping activities, we got a keyword here called if, okay, and we still follow it up with a Boolean expression. So if my password is equal to the word password, then I can print my access as granted. If it's not equal, then I print nothing. So if we look at this, realistically, you've got this input statement here that brings in some variable. You need something to check, just like the control variable from the while loop. We had to bring that in before we could use it. We got to do the same thing with an if statement. You have to have some information here to check. Then you've got a condition. It's always followed by the keyword if. So the condition here just has to be a Boolean structure. It has to evaluate true, false, yes, no, and we can use the same logical operators we always did with the while loops. So here I'm going to say if the password I typed in is equal to the word password, then I'm going to print access granted. So my condition and the selection heading is always going to follow up with the colon. And then in Python, the most important thing is that indentation. So where you kind of bring things over, those make the blocks of codes. If I type the password as password, it's going to print it. If I type it as anything else, it doesn't print anything. And you can kind of see that here if I were to open up this program and run it. Let's just take a peek. I can enter the password. If I type password, you're going to see it says access granted. But if I were to run it one more time and type in something else like not password, anything, it just completely ends. It's like this never existed, which is exactly what we want it to be. Okay. If we wanted to manipulate it to a password of our choosing, all we're really doing is changing this word, and then we can change it to anything we want. If we wanted to make it so it wasn't case sensitive, it's kind of an interesting little thing. We can manipulate the word that we typed in so that it's like all uppers or all lowers. So there's a couple ways to do this. I can go .lower here, and what that'll do is change my password to its lowercase version, and then I can check it across the lowercase version. Or I could do it here as well. The only issue with doing it here is it actually changes the value of what you typed in. So it's not actually what you typed in anymore. So where you put it kind of depends on how you want to work with it. If you know the password's supposed to be in lowercase, you can just force it to be. And that way if I run it now and I can actually type password in like goofy case, and it's still going to work because it got changed to its lowercase version, which is kind of neat. I could do upper, I could do capitalized, title case, all sorts of different things, but lower and upper are pretty much the standard there. Alright, so again, these Boolean operators, you got equal to, not equal to, greater than or equal to, less than or equal to. They all work the same way here as they did with the while statement, so really nothing new there. The indentation is the most important part of this, making sure that you get the blocks of code that make consecutive lines of code within the block. If you dedent or indent too far, things are going to get screwed up. If you've got multiple statements to run in one of those blocks in that if or else block, then you got to make sure they're all following the same indentation level, because if they're not, things are going to get screwed up. So you got to be very, very careful about those blocks of code. So here's that if-else structure in this access or granted or denied program. So here I've got basically the same sort of thing, password. I've got if password equals secret this time, it says access granted. Otherwise, it says access denied. So this is just an improvement on the other program in the sense that at least we get something to print one way or the other. In the previous program, nothing printed when we missed the password, but at least now it'll say that we can do something. So basically, if the user enters the word secret, it'll print access granted. If they don't, it prints access denied. What's missing from the else clause that the if has? Oh, the one thing that you'll never put with an else is a condition. There's no reason to. basically the else is going to run when the condition for the if is false. So what's there to check? So don't even bother putting anything. So never put anything next to the else here other than a colon whatsoever. If you do, it's actually going to be some sort of error. So if I came over here and kind of ran it so you can see it, like I could say if else password not equal to secret, oops, it's going to have a fit with me because I can't really do that even though I spelled password wrong. You can't do it. It's expecting a colon. You can see it right there. So anytime you have the else clause, never ever ever type any kind of condition with it because it's always going to run when that's false. Whoops. So here we go. Moving on. So like I said, the else clause is basically just going to follow any if that you want to run to be the other part, the counterpart to your if. It's always going to run when the condition's false. So keep it pretty simple. I don't think you'll have much trouble with it, to be perfectly honest with you. Okay? So let's kind of see if we can practice this. It'll say slow down if and only if. I feel like we just did these, didn't we? So we should be, we're going to write this in Python. So let's practice writing those bit of logic in Python. So exactly what I wrote here and here, let's see if we can write that in Python. So let's make a quick new file, selection example, and I'll give you all this code too, so you don't have to worry about writing it yourself. But here we go. Let's do the password, or the, what was the other one? The speed program. So we'll do a quick speed input. If I can type. See, it's not just at school that I can't type. Enter the current speed. And then I might say something like, if the speed is greater than 65, colon. And then as soon as I press enter here, it's actually going to indent it for me, so I don't even have to worry about it in PyCharm. It does it in idle too, but again, I like PyCharm better. We're just going to simply print slow down. And that's it. Remember, that was a pretty simple program there, so we'll just kind of keep it that way. Right now I'll run it, and you'll see enter my current speed. If I enter something like 70, which is definitely above 65, it's going to print slow down. If I enter like 50, which, not 0, but either way, 0, definitely less than 65. But let's try 50 again. And it says exit. But what happens if I try 65? Hopefully you notice that 65 doesn't make it true. Not debugging. Okay. And I enter 65, and 65 is actually an okay speed. Okay. It's only when I get above it. Okay. Alright, so let me comment that out real quick. And let's try the other program. This is the SAT program. So we'll do another int, or we'll do SAT score equals int input, enter your SAT score. And here's the if-else structure. So we're going to print you are accepted if the SAT is above 1400. So if your SAT is greater than 1400, colon, print you are accepted. Else, so this is where I actually have to back it up, because even though I press enter here, it wants us to continue making chunks of code, blocks of code. So we'll back it up, we'll put the else colon, and then we'll print, sorry, you were not accepted. Okay? So again, if I run this, I'm going to enter my SAT score. Let's say I enter like a 1450, definitely above 1400, so I'm accepted. If I run it, and I say I give them like a 1200, sorry, not. If I go dead on to 1400, hopefully you already know what's going to happen. It's not strictly greater than, so it throws a false for the condition, and it says I wasn't accepted. If you want to make it so that you were accepted on 1400, just simply make it greater than or equal to. So it's really pretty simple. Okay. Alright, mutually exclusive events. So those were one-way and two-way events. There are some questions that you need to answer that have really kind of more than one option or more than two options. It's not always a simple yes-no kind of deal. But we can always break it down into yes-no. So let's just think about like your grades. Your test scores, they can be an A, a B, a C, a D, or an F, right? So you've got like 5 different choices based on one score, and you should be able to determine what's going on there. Now, to use the structures we currently have, things get a little complicated, so you can think about coming in with some sort of input for a score, and if that score happens to be greater than 90, we can print it's an A. Otherwise, we're not greater than 90, which means we could be greater than 80. Whoops. Let me go back. And that way, in case it's a B, and if it's not, then could be a C, and so on and so forth. So you kind of see how this tails off here, and it does the same thing in code. If my score is greater than 90, print an A, else, and then I got to check another condition, so I start nesting these things in each other. If my score is greater than 80, I can print a B, else I can print a C and then print a D, and if it's none of those, it's print an F. There's got to be an easier way. What I don't want to do is have my program like scaffold off like a set of staircases here. It just gets awfully ugly. So what we can do with mutually exclusive events is introduce one other kind of keyword here, and it's called an elif, which is short for else if. And it allows me to kind of chain together some of these true and falses to pick out one event over any of them and then just run the one event. So what it ends up looking like is pretty simple. I bring in a score and I say if my score is greater than 90, I print an A, and then I come up with an elif. And again, this isn't a strict else, it's an elif, so it has kind of that question word in there, so you want to still judge a condition. If my score is greater than or equal to 80, print a B. If greater than or equal to 70, print a C. If greater than 60, print a D. And else, so if I'm none of these, then I must be an F. Now the trick here is, notice how when I do this, run this program, I only ever get one output. God bless. All right. So if I type in a 95, I get an A, which is greater than 90. So all of these other things get skipped. Even though a 95 is greater than 80 and 70 and 60, it's not going to print them all, because with a mutually exclusive event, it means it can be one of the options or none of them. So once I hit on this score being greater than 90, all this other stuff is skipped and completely passed over, just like the else is skipped when the if statement's true to begin with. And if it's false, then we just move on to the next one, and I just keep moving from there, which is kind of cool. So it kind of really clears it up and straightens things out. We only ever get one score no matter what. If I typed in the 95, I got an A. If I typed in a 65, that's because this was false, this was false, this was false, and finally true. And if I typed in a 53, none of these were true, so it must be the else part, okay? So you got to be pretty neat about how you do this. Things got to stay nicely organized, and in the next set of programs we're going to introduce some sort of issues that you might run into with this. So here's the deal. Just like we did in class the other day, I want you to take a minute, and obviously you're not going to type this into the computer because I didn't give you a code to do it, but go ahead, pause the video for a sec, look at it, and see if you can figure out where it fails. Okay? Alright. If you were able to kind of figure it out, hopefully you can see that it screws up when you type in something that is between like a 80 and a 90%, which should be a B, right? But the deal is, like an 85, well, it's not greater than a 90, so it's not an A, but an 85 is definitely greater than a 70, so it's going to print C, and it's never going to get to this B part. So you've got to make sure things are organized. I always like to do it from like highest to lowest or lowest to highest. It doesn't matter which way you go about it, just as long as you stay organized. You can't start skipping around from 90 to 70 to 80 to 60. That's a big no-no. You just can't do that. It's never going to work the way that you intended to. Alright, again, pause it for a sec and look at it and see what you can figure out for this one to see if it actually works the way that you want it to, and then we'll talk about why it might not. Alright, in this one, even though it's kind of backwards, it does actually work pretty well. So either way, if I type in a score that's less than 60, it's going to print it was an F. If it's less than 70, it's going to print that it was a D. 80, it's completely reversed from where we were. So this one actually works pretty well. Nothing to really worry about in this particular structure. It's well organized. This one's tricky, so go ahead, pause it, take a look. And if you want, let's look at it together for a sec. So here, this one's organized pretty well. But what you notice here is that everything's an if. Okay, which means that this is actually a one-way selection structure, followed by another one-way, followed by a one-way, followed by a two-way. So let's go ahead and, like, if you were to type in like a 95 here, it's going to ask this question. 95 does make an A, so this is going to be true, prints A. But since this if statement has nothing to do with the one above it, it's also going to print a B and a C and a D. So when you're working with these mutually exclusive events, you better put in those elifs for all those other structures that you don't want to have fire when something is true above it. So you got to be really, really careful there. So make sure you stack it with the right structure. All right, again, take a look at it and pause it for a sec, and we'll talk about what might be wrong with it. All right, again, this one's tricky, but this one's actually riddled with syntax errors. The indentation's all messed up. Notice how the print statement's like indented here, almost in line with the C and score, and then you come down here, and you can just tell straight down the line, it's not the same indentation level. It's like 2 characters off, and this one's like 2 characters that way, and this one's all over here, and this one's finally back in the right place. You got to be careful with that indentation. This one's kind of hard to see, but if you're not consistent and you're not letting the editor help you, you're going to end up with all sorts of issues, so be careful with that too. Okay. Alright, last little quick thing here that I think is kind of neat with randomness, a lot of selection when we deal with randoms. So we talked about how we can do randoms for integers using like rand range and rand int, so I'm not going to spend much time with that anymore. Go ahead and pause it and look at the functions or go back to any of the programs we've done before. But I want to introduce at least one more new function. It's called random.choice. And random.choice is kind of neat because what it'll do is randomly select an element from a sequence that you give it. I know we haven't talked about sequences yet, and that's actually not until the next unit, but it's cool enough to kind of at least see what's going on. So in this program here, I've got options, and I've got 4 options. I've got collect homework, homework quiz, everyone gets a 10 out of 10, and no collection, no points. But you notice that it's wrapped in parentheses. When I put elements separated by commas and parentheses or in square brackets or braces, what it does is it creates a sequence, something. There are different kinds of sequences. This one specifically is what we call a tuple, but it's a sequence nonetheless, which means it's just an ordered collection of things, in this case strings. So down here, what I have here is a random.choice function running on options, and options has 4 options. And so what happens is selection gets one of those 4 options randomly, which is kind of neat. So every time I run this program, I get a different output, or at least one of 4 possible outputs. So I might run it one time, and if I print selection there, it says no collection, no points. If I run it again, it says collect homework. Run it a 3rd time, everyone gets a 10 out of 10. Run it a 4th time, it says collect homework, which is the same as the 2nd time. So kind of neat how you can stuff a bunch of choices in there in that options kind of variable, as long as they're wrapped in those parentheses, and work with it. You can actually do this with strings too, because if you remember, strings are just a sequence of characters, and it will pick out like a random character from that string as well. So kind of neat how you can work with that. So we'll play with that some when we get into our guessing games down the road. So let's go through at least one quick option here. We're gonna do that guessing game a little bit more. Here we're going to design the logic for a guessing game that will calculate a random value from 1 to 10, just like we did before, and take a single guess at the value. If the guess is greater than the random value, it should state that it's too high. If it's less, it should say it's too low. And if the guess was correct, it should congratulate us. The game should continue to be played until we win, and it should congratulate us with 3 random message choices. So let's kind of maybe pseudocode this out or flowchart it out, whichever. Maybe we'll just pseudocode it and we'll see how it goes. So let's see if I can kind of bump over the screen. There we go. So let me first, let's go do a flowchart for this one. So we'll make a new diagram. We'll go with guessing game. Come on. 2.0. Oh, jeez. Alright, and again, I'll give you this flowchart so you can see it. We'll pick a new folder. Programming 1. Unit 2. There we go. Internet must be slow. Sorry. Don't know what the deal is. There we are. Alright, so we've made flowcharts here before. Let's get into this. So first and foremost, bring up a start. I'll see if I can kind of zoom in here a little bit. Whoa, 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 whoa. Okay, there we go. Now you can probably see that a little better. Alright, so we'll do some start, we'll do some declaration. So where's my process symbol? There it is. Alright, so far as declare, what I'm going to declare. In this problem, I am going to need a random number from the computer. Okay, we're going to need a guess from the user, and we're going to need a bunch of options for our message. Okay, and you know what? I'm going to set those up right now in here. And we'll just say, congrats, good job, way to go, partner. Keep it simple, short. There's my collection of things, right? No big deal there. That's everything I need. So first thing we need to do is we are going to set a random value. To a random number, 1 to 10. Right, to a random 1 to 10. We're going to get input from the user. Oh, wrong symbol. We're going to tell the user to take a guess. Right, and we'll connect all these with some flow lines as we go. Alright, and let's see, we are going to come up with a decision symbol here. Where's it at? There we are. While the guess is not equal to the rand num, okay, we're going to probably print out it was incorrect. And then we're going to want to print whether or not the guess was too high or too low. So we're going to make another decision here, and this is different than what we did in the first version of our game. So here we need to come up with a new structure. I'm going to move this over just a little bit, and it's going to be a two-way structure because we're going to print it was either too low or too high. We can never do both. We got to print one or the other. So here's the deal. If my guess was, say, greater than the rand num, okay, if that's true, then what I want to do is print it was too high. And if it wasn't, I want to print it was too low. Right? So here we go. We're going to get the flow lines going through here again. So we'll get that connected here, down to here. And now here's the tricky part, getting this connected to here and over to here. And then getting them kind of bounce back together and then back up and around. So here we go. We're going to do this here and this here. Get those going. We'll drag that down a little bit to see if we can give them a match because I am crazy like that. There we go. And then we're going to get this to kind of curl and down and bounce up and out. Whoops. And over. Okay. So here, if the guess is not equal to random num, if that's true, if the guess is greater, we're going to say that's true, false. Alright, and then if that's all happening there, I'm going to grab these and move them over just a wee bit. Oops, messed up my stuff. I'll get that fixed later. But either way, we'll reconnect that. Okay, so now I need to display one of those random choices. So that's what we're going to do. We're going to print a random option. Okay, and then my program's over. I think we got this. So here we go. And it's not the cleanest flowchart I ever put together, but I think you get the gist and how it's going to work. So go ahead, you can kind of take a snapshot of that. Again, I'm going to send that to you, so we'll just save it real quick. I'll load it up to Google Classroom so you can look at it too. But let's go over here and kind of code it real fast. We're going to make a quick guessing game out of this. Version 2. We're going to import random, because we're going to need that. Okay, and we're going to set up our options, like we said, which is going to be a set. We're going to say good job. We're going to say, what else did we want to say? We wanted to say way to go and congrats, right? Oh, I hope my mouse doesn't die. Alright, so there's my options. Now it's time to get the random number. Range from 1 to 11, because remember we don't actually include the stop value. And let's grab some input. So let's back that back where it's supposed to be. So we're going to get our guess, which is equal to int input enter guess from 1 to 10. Alright, while that guess is not equal to random, we're going to print it was incorrect. Oh, there was one thing I forgot to do in my flowchart. Maybe one of you figured it out. Shout it out before anyone else does. Then we got to say if my guess is, say, greater than my rand num. I know it can't be equal, so I'm not even going to bother with the equal to. I'm going to print it was too high. Okay. Else, I'm going to print it was too low. And hopefully somebody shouted it out. I forgot in my flowchart to change my control variable. I never got new input. So I need to grab this and do it one more time way down here. So let's bring that over. And that is something I completely forgot to do. So we're going to delete that flow line. We're going to bring this here, grab another one here, essentially put those together. And we're going to grab a flow line that comes from here and bangs it all the way around. That's what we forgot to do. Whoops. I lost it there, didn't I? Alright, if we forgot to grab new input, well, that would just mean we get stuck in an infinite loop. So let's go back and do that now. We got to grab that input. So I'm basically going to do this line of code one more time. But I want to make sure that it's in the loop, but not inside one of the conditions. Okay? And then when we're all said and done, we can finally print a random.choice from my options. I could do this in 2 lines of code by like getting a selection and making it equal to random.choice of options and then printing out the selection, or I can do it all in the same thing, so it really doesn't make a difference. So let's give it a shot. I have no idea how it's going to turn out. I don't know what the random number is, but I'm going to guess something like 5. It says incorrect, too low, so I'm going to enter in like an 8. Oh, I got it. Alright, sweet. So anytime you're testing these things, always a good idea just to print the random number. Doesn't have to be anything special, but print it so that you know your 2 lows and 2 highs are actually working the right way. Oh, I don't want to debug. Close that. I want to run it. Alright, so I know the random number is 4, so if I pick 5, it should say it's too high. If I pick something like a 1, it should say it was too low. And then if I pick a 4, it should say it was correct. Way to go. And I get a different answer than I did last time. Last time I think it said good job or something like that. This time it said way to go. So it seems to be working just fine. So maybe longer than you expected, but I kind of went through that quickly as far as the lesson, because usually I take about 1 to 2 days to kind of talk about that. So hopefully you get a chance to watch this, and now you can apply it. So I'm going to post everything in Google Classroom. I've got a worksheet there for you to start working on. So why don't you try and get through some of that. You'll see that those are kind of easy, and they bring stuff together. But yeah, get into it, see what we can do. I will check you out on Wednesday and we will clear up any misconceptions. But hopefully this video kind of helps. I'll also post some other tutorials and things maybe could help from other people that might go in more depth or do things a little bit differently. So be looking for that as well. All right. See ya.